Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of a solid into which the front view face, the top view face and the left hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection view over here. Now using the constructional details of the engineering object available with us through this 3D isometric projection, we are required to evaluate front view orthographic projections, top view orthographic projections and left hand side view orthographic projections of the solid. So in order to determine the orthographic projections of the solid, we need to evaluate the dimensions of the front view face, the top view face and the left hand side view face of the solid. Now when the observer is going to look at the solid from the front view orientation, so we observe that the width of the solid, it is equal to 118 millimeter. So here we have got 100 millimeter length up to the center point from the left hand side face of the solid, and then we have got this circular hub over here. So corresponding to this hollow cylinder, we have got diameter, it is equal to 36 millimeter. So this radius, if we add into this 100 millimeter dimension up to the center point, so we obtain that the total width of the solid, it is equal to 100 millimeter plus 18 millimeter equal to 118 millimeter, and the height of the solid has been provided to us as 63 millimeter. So the total distance from the base up to the top face of the solid, it is equal to 63 millimeter. So the front view face of the solid will be measuring 118 millimeter width by 63 millimeter height of the solid. Now when we look at the solid from the top view orientation, now we observe that the width of the solid, once again it is equal to 118 millimeter, while the depth of the solid has been provided to us as 75 millimeter. So the top view face of the solid will be measuring 118 millimeter width by 75 millimeter depth of the solid. Now when we look at the solid from the left hand side view orientation, so we observe that the depth of the solid happens to be 75 millimeter, while the height of the solid happens to be 63 millimeter. So the dimensions of the left hand side view face of the solid, it will be measuring 75 millimeter depth of the solid and 63 millimeter height of the solid. Let us proceed to evaluate orthographic projections of this engineering object. So now in order to obtain the orthographic projections of the solid, we have drawn the XY reference line, we have also drawn the X1 Y1 reference line, and we have also obtained a transfer line originating from the intersection of XY reference line and X1 Y1 reference line, and this transfer line happens to be inclined at an angle of 45 degree with respect to the XY reference line, and this transfer line we are going to require in order to transfer the distances alongside the depth of the solid from the top view orthographic projections into the left hand side view orthographic projections over here. So now since we are required to obtain the orthographic projections of the solid into the first angle projection method, so the front view orthographic projections, they will be obtained above the XY reference line, the top view orthographic projections of the solid will be obtained below the XY reference line, and the left hand side view orthographic projections of the solid will be obtained on the right hand side of the front view orthographic projections above the XY reference line. So now we know that the dimensions of the front view face of the solid. They are measuring 118 millimeter width by 63 millimeter height. So in order to obtain 118 millimeter width, we have drawn two vertical projector lines into the front view orthographic projections, which are separated by a distance of 118 millimeter, which happens to be the width of the solid. And these two vertical projector lines we have appropriately transferred or projected into the top view orthographic projections over here, because in the top view orthographic projections as well, we are going to require width of the solid equal to 118 millimeter. So now we know that the height of the front face of the solid, it is going to measure 63 millimeter. So now we are going to measure a distance of 63 millimeter above the XY reference line or the ground level and obtain a horizontal projector line into the front view orthographic projections, and we are going to extend this horizontal projector line into the left hand side view orthographic projections over here, because into the left hand side view projections as well we are going to require height of the solid as 63 millimeter over here. Now let us proceed to evaluate the top view face of the solid over here. So now we can check the width of the solid into the top view projections, that is 118 millimeter. So this we have already obtained while we extended these two vertical projector lines into the top view projections over here from the front view projections. Now we know that the depth of the solid into the top view projections, it happens to be 75 millimeter. So now we are going to draw two horizontal projector lines into the top view projections, which are separated by a distance of 75 millimeter, which is the depth of the solid. And these two horizontal projector lines, we have appropriately transferred them into the left hand side view projection view using this transfer line, such that into the left hand side view projections also the depth of the solid will be transferred as 75 millimeter from the top view projections over here. Now let us proceed to evaluate the front view orthographic projections of the solid. Now we can divide the solid into three components over here. So here we have got a horizontal web at the base, which is carrying a rectangular hole or a slot at the base of the solid, and it is also carrying two circular holes over here which are separated by a distance of 45 millimeter. Then we have element number 2, which is an inclined vertical web, and this inclined vertical web, it rests centrally on top of this horizontal surface over here, and this web, it happens to be parallel to the front face of the solid. Then here we have a hollow cylindrical element over here, which is going to be our element number 3. Let us proceed to evaluate different elements of this engineering object alongside the width of the solid. So now we can check. Here we have got a center point over here, which is at a distance of 18 millimeter from the right hand side face of the solid. So this is the right hand side face of the solid available over here. So now from the right hand side face of the solid, we are going to measure a distance of 18 millimeter over here. So this way, this distance we have measured as 18 millimeter. So automatically this distance of the center from the left hand side face of the solid, this is left side face of the solid. So the distance of the center of the cylinder from the left side face of the solid, it is equal to 100 millimeter. So now from this point we have obtained a vertical center projection line into the front view orthographic projections, and we have appropriately extended this vertical projection center line into the top view projections over here. So now since we know that the diameter of this outer cylinder happens to be equal to 36 millimeter. So from the center point, we have already taken an offset of 18 millimeter onto the right hand side. Now we need to take another offset of 18 millimeter onto the left hand side in order to identify these two extreme diameter end points over here into the front view projection. So now this end point we had already defined. It is lying onto the right hand side face of the solid. So now from this center point we have taken an offset of 18 millimeter onto the left hand side, so that this point corresponding to this diameter of the outer cylinder, it can be obtained into the front view projection. So now having marked this distance of 18 millimeter, now we have obtained a black vertical projector line corresponding to the end point of the cylinder into the front view projections, and this black vertical projection line we have appropriately extended it into the top view projections as well. Now we know that corresponding to this hollow cylinder, there is the inner portion of this hollow cylinder over here. So the diameter of this inner cylinder, it happens to be equal to 22 millimeter. So now we have to define these two end points of this interior part of the hollow cylinder into the front view projections over here. Now how do we obtain the end points of this hollow cylinder over here? So we have to draw an offset of 11 millimeter onto the left hand side of the center line and 11 millimeter towards the right hand side of this center vertical projector line over here, so that the distance between these two black vertical projector lines which we have obtained into the front view projections, it should be equal to 22 millimeter, which is the diameter of inner hole of this hollow cylindrical component over here. And these two black vertical projector lines, we have appropriately once again transferred them into the top view projections as well. Now next thing we know that this portion corresponding to element number 1, that is the location of the center corresponding to these two holes into this horizontal web. So this center point, it is located at a distance of 28 millimeter from the left hand side face of the solid. So from the left hand side face of the solid, we have measured a distance of 28 millimeter, and one vertical center projector line we have appropriately located into the front view projections, and we have extended this vertical projector center line into the top view projections as well. Now we know that the diameter of these two circular holes which are going to overlap into the front view orientation, it is equal to 12 millimeter. So now these two end points of this circular hole need to be located into the front view projections over here, and this diameter being equal to 12 millimeter, now we are required to take an offset of 6 millimeter onto the left side and 6 millimeter onto the right side of this center point over here. So from this center vertical projector line, now we have to take an offset of 6 millimeter on the left side, 6 millimeter onto the right side, so that the distance between these two vertical black projector lines into the front view projections, it becomes equal to 12 millimeter, which is going to define these two end points corresponding to the circular hole. And these two vertical black projector lines, once again they have been appropriately transferred into the top view projections as well. Now next we have got this distance is also equal to 28 millimeter, because we can check total distance is 56. So the center distance from the left hand side face, it is 28. So the center distance to the right hand side face of this horizontal web, it will also be equal to 28 millimeter. So now we have taken a distance of 28 millimeter from the center point of circular slot, and we have obtained the end point, that is the right hand side end point corresponding to this web number 1 or the horizontal web number 1. So here this vertical projector line, we have appropriately located it into the front view projections and we have transferred it into the top view projections as well. Now we know that here we have got a rectangular slot at the base of the element number 1, that is a horizontal web, and this leg of the base, it is having dimension is equal to 12 millimeter width over here from the left hand side face of the solid. So now from the left hand side face of the solid, we have taken a distance of 12 millimeter and now we have obtained a vertical projector line into the front view projections and we have extended this vertical projector line into the top view projections as well. Similarly, from the right hand side face of this element number 1, again we have got a vertical leg over here and this distance, it is equal to 12 millimeter once again. So now from this extreme point of the horizontal wave, again we are going to take a distance of 12 millimeter onto the left hand side, and again corresponding to this vertical edge of the second leg of the horizontal web over here corresponding to this rectangular slot. Now one vertical projector line, it has been obtained into the front view projections and this vertical projector line has been appropriately transferred into the top view projections as well. And finally the last element is this one alongside the width of the solid, that is from the center point. If we take a distance of 36 millimeter towards the left hand side portion of the solid, so we are going to locate this junction point between this horizontal surface and this inclined surface of this inclined web over here. So now from this center point, it is this center point, we are going to take a distance of 36 millimeter towards the left hand side face of the solid, and this junction point between the flat surface and the inclined surface, it will be determined over here. And here we have obtained one vertical projector line at a distance of 54 millimeter from the right hand side face of the solid, or 36 millimeter from the center point over here. So this vertical projector line has once again been transferred into the top view projections over here. So this way all the elements of the solid, based upon the construction of the solid alongside the width, they have been appropriately plotted into the front view orthographic projections. Now let us plot various elements alongside the height of the solid. So we know that corresponding to this rectangular slot at the base of the horizontal web, so this height is equal to 5 millimeter. So we have taken a height of 5 millimeter above the XY reference line, and now we are going to obtain one horizontal projector line at a height of 5 millimeter above the base of the solid into the front view projections, and this horizontal projector line has been appropriately transferred into the left hand side view projections over here. Next we have got height of element number 1, that is horizontal web, it is equal to 15 millimeter. So now we are going to mark a height of 15 millimeter above the ground or above the XY reference line, and another horizontal projector line we have obtained into the front view orthographic projection view, and we have extended this horizontal projector line into the left hand side view projections as well. Next we have got this height of this hollow cylinder. So from the top surface, if we move down by 25 millimeter, so we will be able to obtain the base of this hollow cylinder over here. So now we are going to mark a distance of 25 millimeter below the top surface of the solid, and we are going to obtain a horizontal projector line into the front view projections, and we are going to extend this horizontal projector line into the left hand side view projections over here. So this way the grid structure corresponding to the various elements of the solid alongside the width and alongside the height. It has been determined over here. Now let us join the surfaces of the solid which will be visible to the observer as the observer is going to look at the solid from the front view orientation. So now when the observer is going to look at the solid from the front view orientation, so this inverted U-shaped structure which is corresponding to the horizontal wave into which a rectangular slot has already been cut over here. So this surface, since it is parallel to the vertical plane, so we are going to obtain the true shape projections of the horizontal wave into the front view projections over here. Next we have got this inclined surface. Now we can see from this center point, if we move back by 36 millimeter, it is this top point which we are going to achieve. From this center point, we have moved back by 36 millimeter. So this point, that is this surface, will be appearing as an edge view, as a point view over here. So here it is this point view. So this point will be connected with the top surface of this horizontal wave towards the left hand side face of the solid. Now we can check here, this inclined web is connected at the base of the solid. So it is this point now we have to obtain over here. It is this point. Now this point can be located at a distance of 25 millimeter below the top surface, 36 millimeter on the left hand side of the right hand side surface of the solid. So we can check 36 millimeter from the right hand side surface of the solid, 25 millimeter below the top surface of the solid. These two endpoints corresponding to this inclined vertical web, they have been located appropriately into the front view projections over here. So now we can check this cylindrical projection. It will be presented as a rectangular projection into the front view projections over here. So here we have been able to obtain apparent shape rectangular projections corresponding to this outer portion of the cylindrical object which we have obtained over here into the front view projection. So this is the apparent shape projections over here. Then corresponding to this inner hole which is having dimension 22 millimeter. So this dimension is 22 millimeter. This interior hole, this will not be visible to the observer from the front view orientation. So hidden projections corresponding to this internal circular hole will be visible to the observer as a dotted line projection over here. Once again, apparent shape projections, they are visible to the observer, whereas these projections, they were true shape projections corresponding to element number 1. These projections corresponding to the inclined vertical wave, this surface is also parallel to the vertical plane. So the projections of this inclined vertical wave into the front view projection, it is a true shape projection over here. Next we have got this circular hole and this circular hole which are overlapping with each other. So again these two holes, they are not visible to the observer from the front side. So corresponding to these two endpoints of the diameter of the circular hole, dotted line or the hidden line projections will be available into the front view projections as apparent shape projections over here. So these are apparent shape projections corresponding to these two overlapping holes into the horizontal web number 1 over here. So this way the front view orthographic projections of the solid, they have been obtained. Now let us proceed to evaluate the top view orthographic projections of the solid. Now we know that this inclined vertical web, it is located centrally alongside the depth of the solid above this element number 1 which happens to be the horizontal web. So the total depth of the solid, it is equal to 75 millimeter. So if we take a distance of 37.5 millimeter from the rear surface or from the front surface of the solid, so a center horizontal projection line we are able to obtain into the top view projections, and we have transferred this center projection line from the top view projections into the left hand side view projections over here using this transfer line. Now we know that the depth of this vertical inclined web, it happens to be equal to 12 millimeter. Now we have to take an offset of 6 millimeter towards the rear side of the solid and 6 millimeter towards the front side of the solid, so that this depth of the web, which is symmetrically aligned alongside the center point of this particular solid, alongside the depth of the solid, it can be located. So now we can check. We have marked an offset of 6 millimeter toward the rear surface of the solid, 6 millimeter toward the front surface of the solid, and two horizontal projector lines we have been able to obtain into the top view projections. And using this transfer line, these two horizontal projector lines, they have been appropriately transferred into the left hand side view projections over here. Now next we have got distance between center points of these two circular holes over here into horizontal web. So we have to take an offset of 22.5 millimeter towards the rear surface of the solid and 22.5 millimeter towards the front surface of the solid, so that this distance of 45 millimeter will be obtained between these two horizontal center projector lines over here into the top view projections which we have obtained. And using this transfer line, now we have been able to transfer these two center projector lines into the left hand side view projections over here. Now we can check that the diameter of this hole towards the rear surface and this circular hole towards the front surface of the solid, it is equal to 12 millimeter. So now we need to evaluate these two endpoints corresponding to this circular hole, these two endpoints corresponding to front side circular hole over here. So once again, 6 millimeter offset toward the rear side, 6 millimeter offset towards the front side. Similarly, 6 millimeter offset toward the rear side and 6 millimeter offset toward the front side we need to take. So from this center line, we have to take 6 millimeter offset toward the rear side, 6 millimeter offset towards the front side, and two horizontal black projector lines corresponding to the circular hole we have been able to locate into the top view projections. And using this transfer line, these two black projector lines corresponding to these two endpoints of the circular hole, they have been appropriately transferred into the left hand side view projections over here. So we haven't extended these two black projector lines up to the top because we know that this circular hole, it is available into the horizontal web which is having height is equal to 15 millimeter. So we have taken these two black projector lines up to the top surface of this horizontal web only. Similarly, corresponding to this front side circular hole, once again 6 millimeter offset toward the rear surface, 6 millimeter offset toward the front surface has been located, so that these two endpoints of the diameter having diameter is equal to 12 millimeter, they will be located appropriately into the top view projections, and two black horizontal projector lines, they have been drawn into the top view projections. And once again, using this transfer line, these two black projector lines, they have been appropriately transferred into the left hand side view projections over here. And finally, we are left with this particular circular block, that is a hollow cylinder. So corresponding to the outer part, the diameter is 36 millimeter. Corresponding to the inner hollow cylinder, it is having the diameter is equal to 22 millimeter. So from the center line, now we have to take an offset of 11 millimeter toward the rear side and 11 millimeter toward the front side of the center line over here, so that this diameter of 22 millimeter can be located appropriately into the top view projections over here. So now, having marked this distance of 22 millimeter in such a way, it is 11 millimeter above the center line, 11 millimeter below the center line. So now, two black horizontal projector lines corresponding to the inner portion of the hollow cylinder, they have been appropriately obtained into the top view projections, and these two black projector lines, they have been appropriately transferred into the left hand side view projections up to the top surface of the solid using this transfer line over here. Similarly, corresponding to this outer part of the hollow cylinder, which is having diameter is equal to 36 millimeter. So now we have to take a distance of 36 millimeter corresponding to two end points of the cylinder in such a way that we have taken an offset of 18 millimeter towards the rear surface of the solid and 18 millimeter towards the front surface of the solid from the center point, so that these two end points of the circular portion, they can be appropriately located. So now another couple of black horizontal projector line, we can see this is this black projector line and it is this black projector line, that is the outermost one. So these two horizontal black projector lines, they have been located into the top view projections and they have been appropriately transferred up to the top surface of the left hand side view projections over here using this transfer line. So this way, all the grid line elements corresponding to the top view projection, they have been obtained into the orthographic projections. Now let us darken the portions of the solid which are visible to the observer, as the observer is going to look at the solid from the top view orientation. Now whenever the observer will be looking at the solid from the top, so this boundary corresponding to element number 1 will be visible to the observer. But one thing we can check, because this portion of the vertical wave, it is going to cover this portion that is at the base. So this little portion at the base, it will be covered by this inclined web over here. We can check this inclined web, it has covered this base portion up to a depth of 12 millimeter at the center over here. So that is why, so this portion of the element number 1, it will be appearing as a hidden line portion, whereas this portion corresponding to this inclined wave, it will be visible to the observer. Then another thing we can check, these two holes, they are visible to the observer from the top view projections. And another thing we need to observe over here, this rectangular portion toward the rear surface, this rectangular surface toward the front surface. So both of these rectangular surfaces, one rectangular surface toward the rear part of the solid, one rectangular surface toward the front part of the solid. So these two surfaces, they happen to be parallel to the horizontal plane. So into the top view projections, we are able to obtain true shape projections of element number 1 into the top view projections over here. Whereas another thing we should observe, that up to this portion we can check, up to this portion we have got the inclined web, up to this portion we have got a horizontal web over here. We can check up to this portion we have got inclined web. After this portion of the web, it is horizontal. So since this portion of the web is horizontal, here we are able to observe true shape projection of this vertical inclined web onto the horizontal plane as a true shape projection, whereas this portion of the inclined web, which is inclined to the horizontal plane, so it will not be projected as a true shape projection into the top view projections over here. So this projection, it is the apparent shape projection over here. Then we have got this hollow cylinder. So the outer diameter is 36 millimeter and inner diameter is 22 millimeter. So this surface is also true shape because this surface happens to be parallel to the horizontal plane. So we are able to obtain true shape projections corresponding to this surface of the hollow cylinder over here. Another thing here, we need to evaluate that corresponding to this rectangular slot at the base of element number 1 or the horizontal wave. So here we have got two edges over here. This is one surface vertical edge, this is another surface vertical edge. So these two vertical surfaces, they will not be visible to the observer from the top. So the hidden line projections, they will be appearing in the top view projections corresponding to these two vertical edges over here. So this is vertical projection which is appearing as a hidden line projection over here. So this way the top view projections of the solid, they have been appropriately obtained over here. Now when the observer is going to look at the solid from the left hand side view orientation, we can check this portion of the left hand side surface of the solid. It will be visible to the observer from the left hand side view orientation. So we are going to obtain true shape projection of this rectangular surface into the profile view over here. That is the left hand side view, because this surface happens to be parallel to the profile plane. Then we have got this rectangular slot. Now we can check this total surface. It is not visible to the observer from the left hand side. Rather, this surface will be projected as an edge view projection into the left hand side view projections over here at a height of 5 millimeter above the ground. So here we are going to observe hidden line or dotted line projection appearing as an edge view corresponding to this surface over here. So this surface will be projected as an edge view projection over here. Then corresponding to these two holes, they are also not visible to the observer corresponding to element number 1. So these two holes will be projected as apparent shape hidden line projections into the left hand side view projections over here. Then we have got this inclined vertical web over here lying at the center between these 2 points. So now we can see this vertical web starting from the top of the surface of element number 1 up to the top surface. This is visible to the observer, but certain portion of this inclined web which is going up to this point, we can check this portion of the web as we are looking from this side. So it is not visible to the observer, this portion. So this portion will be appearing as hidden line or dotted line projections from the left hand side view orientation over here. So this portion is not visible, but this complete portion above the top surface of this horizontal web, it is visible over here to the observer. But we have obtained apparent shape projections corresponding to this inclined wave into the left hand side view projections over here. Then corresponding to these two circular portions having diameter 36 millimeter and diameter 22 millimeter. So the outermost portion of the cylinder, this will be visible to the observer, but this portion of the cylinder, we can check this portion. So this portion, it will be covered by this web and this will not be visible to the observer. So this portion of the cylinder we have taken as hidden line projections, whereas we have been able to obtain apparent shape rectangular projections corresponding to this outer cylinder having diameter is equal to 36 millimeter. Similarly, this inner hollow cylinder, it is not visible to the observer from the left hand side orientation. So we are going to observe hidden line projections corresponding to these two end points of the cylinder over here. So corresponding to these two end points, we are able to obtain apparent shape rectangular projections over here into the left hand side view projections. So this way we have been able to complete the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections corresponding to an engineering object for which we had been provided with a 3D isometric projection revealing the constructional details of the object. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.